So I'm Nathan. Online I go by Myobi everywhere, so if you want to follow me or something, it's fine, I guess. I live in Berlin. I moved there to work on Wunderlist years ago. So I'm a product designer and developer, I guess. I started as a graphic designer, actually, a long time ago, and then things have just spiraled out of control, and now I'm at Rabbit conference. So I used to work at Wunderlist, and now I work at Microsoft because they bought us. They're very nice. They're good people. I can recommend them. Also, I like sneakers. So if you're into sneakers, you need to talk to me later. So the ones I have on are these. These are Nike Cortezes that were made in collaboration with Kendrick Lamar. They're called the house shoes. He just won a Pulitzer. I don't know if you know that. So either way, he's very important, and you should know him if you don't know him already. So, like I said, I used to work at Wunderlist, and it's a to-do list app. It's this is what it looks like. It's not that fancy. You can put tasks in it, but it has a feature that is real-time collaboration. So you make changes, people you share lists with see them very quickly. Our goal was that it would be less than 5 seconds for someone to receive a change anywhere else in the world. That's a pretty tough goal. Yeah, we wanted it to feel like you were like remote controlling the other device. And so to do that, you have to have a good event bus, basically. That's a spoiler to the story. Either way, Wunderlist version 1, just for some quick history, I never used it. I never really saw it. I found this screenshot somewhere. It was just a single user app. I think they made it in like 3 weeks or something. And people really liked it. Christian was the CEO, and they were working on another product, and then they decided, okay, people like this thing better than our other product that we made in 3 weeks, so let's do it full time. They made it with Titanium. I don't know if you remember Titanium, but it's one of those OG JavaScript frameworks. Like you could build your app in JavaScript and deploy to multiple things. This is like before Electron and before React Native, you know. Either way, then they realized Titanium wasn't a good idea, and so they made Wunderlist 2, which I could only find a screenshot where less than half of the screenshot is Wunderlist 2, but either way. The big feature was that you could share a list with other people, and you could collaborate on that, add tasks, and you would see each other's tasks. They also wrote everything to be native. So that was a big effort they did. I keep saying they because I didn't work there at this point. People liked it again, which was good. It's good. But they had problems. Scaling is really hard, no matter what you do. When you have a lot of people that want to use something, it just seems like you never have enough of whatever it is that they want, right? So it wasn't anything like in particular that was a problem. It's just kind of everything was a problem. There was also a few data synchronization bugs, like you could add a task to a list and the other person would just never see it. And that was really, really hard to diagnose. I will say, just don't use timestamps for anything. That's just my advice. Don't do it. Just don't do it. I'm serious. Okay, so they decided they needed to rewrite everything. The team did. Like they were like, we got these data sync problems, we got scaling problems, but we got good reviews. So let's rewrite everything so that we have the same app, but it actually like we can scale it and it doesn't have data sync issues. And so then I was like, oh, I want to help with that. I think that's a good idea. It's never a good idea to rewrite. Everyone always tells you that, but then when you hear it, you're like, this is a great idea. So either way, it was a party, and so I put the party emoji. So that became Wunderlist 3, which is the current version. That's the one that I worked on. I did find a better screenshot of it, so that was the Mac app there. The big feature now was not just data sharing, but that it was going to be real time. And so we thought that sharing a list, it would actually, if we forced ourselves to make it what we call real time, which is that 5-second change, it would actually make it more reliable, make customers trust it better. So at least we think so. Yeah, so we wanted the data sync to be reliable, so we get rid of the timestamps and move to monotonic clocks and things like that. It turned out that we didn't want our server to be very intelligent. The client could be intelligent. So really all we needed the server to do was just be very, very fast at moving stuff back and forth. Kind of like, yeah, again, spoiler alert, like we were going to use Rabbit for that. We also wanted it easier for the team to build new features. The old way that it worked was a lot of coupling. It was really difficult to make changes. It was really difficult to do new things or to do experiments. So that was actually something we also wanted to happen. And it turns out when you use something like Rabbit as an event bus, you actually get this for free, because then you can just kind of do things. You can set up extra bindings. You can set up new queues, and you don't have to ask anyone. So We also built a lot of AWS tooling and stuff because we're all on AWS. It's still on AWS. They did not move it to Azure. They did have an effort to do it, but it turns out like vendor lock-in's a real thing and you can't move. Like you just can't do it. Either way, I and the team and everyone else spent 13 months to rewrite everything. That's a long time to work on a project where you end up pretty much where you started. So I don't recommend it, but it was fun sometimes. We decided to use Rabbit. We knew that the event system was going to be a single point of failure. So we're like, let's do a good single point of failure, right? So instead of just trying to remove it. It doesn't really matter, but we actually, for some reason, we liked the idea that it was written in Erlang. None of us knew Erlang. We didn't really know what Erlang was, but we had heard about it being good and old. And we were like, that's really cool. And maybe it'll work. Maybe it'll work better than the things that we would make. So it turns out that's probably true, but it doesn't really matter. That's not the way you should evaluate a product. And I found a cool picture of a bunny. So you got to have that, I think, in this type of venue. So we used Cloud AMQP back in the day. Really recommend them. Like hashtag shout out. Carl and his team really honestly helped us. We could not have done it without them. I don't know, like we didn't want to run it. We were really bad. Everything we tried to run did not work. So we were like, someone else has to do this. And it's really the only vendor we had that like didn't screw us. So like AWS screwed us, everybody screwed you. Carl has not yet. So yeah, so people always ask me then to explain, well, why is Rabbit good? And I would say, I don't know if I would say it's good. It's kind of like Vim and Emacs. Like those are very good editors, but I don't tell people they should use them because you have to be a very motivated person, right, to use those because there are like nuances and you have to learn. And so that's the way I explain it. Is like if you're motivated, it's very good. If you're not motivated, I don't know, man. Like you really might get into something. Either way, a lot of tech has similar learning curves. So yeah. It also causes it to shift your mindset. You're no longer like SQL based, which a lot of startups, everything's in the SQL database at first, and then you kind of rip it out little by little. So it's good to have that shift of mindset forced upon you. So embrace it, do it. We decided to do an evented architecture. So a lot of people were very weary because they were like, oh, transactions in SQL, that's very stable. And it's like, it's not actually very stable. It's only stable in the transaction. And that's like, you know, at the end of the day, you can't scale that. So sorry. Well, you can if you have like, you know, a lot of money. But yeah, so either way, what do I mean by evented? Because I think when people say that, it's meaningless. Basically, this was going to be our kind of API that we talked about internally. Like you can throw stuff in and you can listen for things, and that was it. That's the way we wanted everything to work on the back end. So that's what we did. It's kind of like Node.js's event emitter, I guess, if you want to think about it that way. I think having something simple that you can talk about, something really dumb, is really good because then you can get alignment and actually go solve the problem. You don't have to worry about people like building something and being like, that's not what we talked about. So I really look for things that are really dumb so I can assemble them into sophisticated things. And I think this was one of them. Also, I like technology. This is a point I put in here that I forgot I put in here. I like technology that teaches me how to do better, and I think Rabbit has done that. Like it's taught me like, oh, okay, like the whole exchange queue thing. I hated that, but it does make sense and it's a good idea. So either way. Also, we weren't really certain that we were going to use Rabbit because we didn't understand it or anything, and so that's why we wanted to be very, very simple with how we used it at first. But again, like lock-in's real. Like you can't move to something else once you start using features. So we were just lying to ourselves. But either way. Also, anything I say is not just me. Like everybody at the whole company is involved at everything, every part. Like I'm not important. I'm just here talking to you. So I just want to make sure that's clear. Everybody at Wunderlist is awesome. They're all doing different things now. Well, not all of them. Some of them are working on a to-do app that's not Wunderlist and stuff like that. So. Either way, if there's something you take away from the talk, you need to learn Rabbit. You need to learn how it works, not even to use it. Just learn it so that you have new concepts to think about when you build stuff. So either way, like, do you know what an exchange is? We didn't know that. Honestly, I kind of wish the default exchange and default queue weren't there. It's very confusing because you read about it and then you're like, but this thing over here doesn't work that way. And it's like, I wish it would go away. Either way. Do you know what the queue really is? We thought we understood it. It turns out we didn't. We did it wrong many, many times. Do you know what a binding is? We had never even heard of that for a while because we were using the default exchange for a long time when we were first testing it. And we were like, this isn't really all that cool. And then once we did the bindings, we're like, okay, now this is cool. How expensive is a binding? Turns out it's very expensive. You can learn that the hard way like we did. How expensive is a connection? It's expensive, but it's worth it because you have to connect. Basically, you need to learn how would Rabbit want me to solve my problem, right? That's what you need to learn, hopefully. Whether you do it or not important, but just this is actually worth learning just for your life. So either way, this is what we learned. Maybe I'm wrong. If I'm wrong, tell me at the end. I might be wrong. I'm not an expert. You push junk into an exchange, and you consume from a queue, and you use a binding to translate between the two. And once we learned this concept, we felt like superheroes because we were like, we can do this now. We can focus on Wunderlist and quit with this junk. So also QoS, you got to learn about that. It sucks. Just look it up. It's the worst thing ever. We could not have built our own versions of what Rabbit does, like the whole binding and the multiplying and the fan out and the whatever. Like I don't think we would have gotten done in 13 months if we didn't have all these features at our disposal. Also, now I get angry when I have to use things that don't have these features. So, we set up 4 primary exchanges because you prototype something and it goes into production. Yeah, we could have done everything with one exchange if we'd have done our routing keys differently, but it doesn't matter. Either way, we did functional sharding. We actually have like tens of rabbits. We don't have just one. So we have like important rabbits, less important rabbits. We monitor some, we pay more for some, and that's the way we did the whole system, so it kind of fit with what we were already doing with our AWS setup. The reason we have 4 exchanges is because we thought creates was going to be overwhelming and we need to move it to a new box, and so we just wanted it to already be separate. So anything that happens in a system, we push it onto the correct exchange with the routing key set to the type of thing that happened. We call it destroy because it was a Rails shop, but also deleted means we updated like a deleted ad or whatever. So, and touch is very similar to what Active Record calls touch, which just means we want to like increment a number, and that's it. We don't want to update anything else, and that's very important. Either way, every change in the system we call a mutation, and I don't remember why. I don't know why we didn't call them changes. I think that's weird. The routing key, like I said, is set to the object type, so it'll be like task, list, subtask, comment, whatever, so that you can know task create, list, update. There you go. Everything's in there. You can consume it. It's fantastic. Everything that happens is powered by this. Like when you sign up and you get a welcome email, it's because there's some consumer bound to the user create. If you get a push notification, it's because something was bound to task create or comment update or whatever. If we want to do a cascading delete, that all happens by like churning through like a million deletes that cascade into other deletes through the system. Everything happens through this. That's how everything works. We set up a queue that binds to all 4 exchanges for all routing keys, and then we call that the mutation stream, and that's everything that mutates in the whole system. That's really nice. You get that for free. Really like that. We had intended to archive them, and then I looked, and apparently we're not. I don't know where they go, but it's there. I call this the river of data because you can just siphon things out of it and do whatever you want with it. It's very nice. Like if you want to build a new feature, it's all there. Everything that happens in systems in there. So somebody wanted to batch push notifications up so that like if I create 5 tasks, you just get a notification that says 5 tasks were created. So they just made a consumer, they bound to the right queues, and they just had it accumulate in memory, and then it would send after a certain delay. They were able to do this without telling me, without telling anyone, and then show, hey, it's working, and then we could just replace the current notification system with that one. That was really nice. I like that. Someone else wanted to do something crazy, which was they wanted, like, you type in the task name, and then it would use Google Translate to translate it to another language, and you name the list like the language you want to translate to. Basically, it was insane. They built this, though it worked. They showed us like in the app, and we didn't even know that anyone had done it until they demoed it. I think that's really nice. I guess some people will be terrified that that's happening, but I don't want to have to know what all's happening. I can't handle that, man. It's like too much. But yeah, so just a reminder, like touch is very important. We increment numbers. That's how we keep track of like what has changed. That feels like the sync protocol. We also use it to have like a parent-child relationship. So when you create a comment, we bubble up the touches. And we do that by enqueuing a new message each time, so into the correct exchange. Then we sync by going back down, looking at all the numbers that have changed, and we eventually get back down to wherever something might happen. Oh yeah, I mentioned cascading deletes. We don't do bulk deletes. We actually would, like if there's 100 tasks under a list, we can queue 100 messages into the correct exchange. We just like it that way. You just get natural flows of information. I don't know, you can look at your graphs, it's fun, it spikes and stuff. We have a queue called events, which are like slimmed down the mutations, all the changes, and these are the ones that go out to the apps. And so if you have the app open, you will receive these events in real time, and they get sent over from Rabbit. We actually have that in a separate Rabbit, and we send it from the main mutations Rabbit over to that one. So we wrote an app called Cerebro, which is like the central router. It has the rules of like who's the parent of who. And there's a couple that have 2 parents, and it's super annoying, but we had to do it for optimizations. But either way, Cerebro has all those rules. It also knows all the bindings, all the queues, and all the exchanges, because it's really important that something knows that. You can end up accidentally not binding and losing a lot of messages and stuff. So if you don't know what Cerebro is, it's an X-Men thing. It's how Xavier can find all the mutants. And so since this knows all the rules of where things go, we thought that would be funny. We rewrote it, and we called that one Cerebra, because apparently that's actually what happened in the comic. Cerebro was destroyed, and they rebuilt it as Cerebra. This one was in Clojure. The first one was in Ruby. Ruby's not good for concurrency with this particular type of thing. Clojure was much better for concurrency, so it just had all the same rules in Clojure. And Mr. Ben Schofield reads a lot of comics, and so he named it. So that was Cerebra. This is his handle, Ben Schofield. He's very cool. And apparently he reads a lot of comics. So I had never heard of that, so either way. Something else that's really important that I mentioned was you need to have your exchange and queue creation in code somewhere, or something. You just don't go clicking around, like never. Like don't click and do something, because you will forget and you'll need to do it again. It needs to be versioned somewhere. Either have a config that when Rabbit boots, it'll apply it. There's a plugin for that. Or have every app that needs something set it up every time if it's not already there. Really important, we have multiple times lost data by throwing it away. And just, you don't have to do it. You can actually not throw it away. I recommend, please put it in code somewhere. I recommend you default to durable, like, or persistent or whatever, just I recommend it as a default when you're testing. If you get performance problems, you'll see it. You should want to get to where you're having performance problems so you'll know when they'll happen. Don't wait on your customers to get to that. So example of non-durable, though, is all the WebSocket messages, all the events that are the slimmed down mutations. We actually set that on we don't care, just because the WebSocket's unreliable anyway. So that's actually a way we can speed that up, but everything else is pretty much durable, and we haven't had any problems. Like, it's fine. I don't know. Maybe they have good disks over at Carl's thing. Another important thing is we do 2 connections per app, publishing, consuming, and then we use channels for concurrency from there. I'm pretty sure that's what you're supposed to do. If it's not what you're supposed to do, then at the end you have to ask the question, and you can tell me that I'm not supposed to do that. We also don't cheat. So if in the same app you could run a function to do the work, we don't do that. We put it back in the queue so that it comes around. Don't cheat. It's very tempting for people to cheat when something's in the same code base. We actually just have a lot of code bases that solves some of the problem, but don't cheat. Just put it back in. The biggest problem people see is that this is implicit consumption, right? It's like you're putting stuff in, it's being consumed somewhere else, and you don't know, did it really get there? It's like, well, just embrace it and get over it. It's good. I usually don't like implicit code. I agree. But coupling is worse. So this is much better. I recommend that your publishers and consumers agree on the schema, but they do not know what each other is going to do. Okay, so it's important that they can talk the same language, but it's very important that they don't know what's going to happen, because something might change in the future. You might do something different with the message. So I recommend that. Yeah, embrace being asynchronous. I know you can do RPC and all that stuff. Don't do it. Just wait on something to come back around. We push the waiting all the way out to the apps or the web pages. Let that thing wait. It can do retries much easier. Whatever. But everything else, fail fast. Don't do it. Just let it go. One thing you do have to do is account for time. Probably you might need to know if something happened before something else. I would not rely on any queue to keep order for me. I don't know. I just don't trust anyone. So come up with a scheme. Have a clock somewhere. We put a clock on everything. So every task, every list, everything has a number, and we increment it when something changes, and that's how we know that time has passed. So I recommend you do something. Don't use timestamps, though. It's really bad. Now, you may say, well, Google uses timestamps. It's like, you're not Google, or if you are, stop it. You're making us look bad. You got to, seriously, don't use timestamps. Use this thing called monotonic clocks. If you don't know what that is, it's a Wikipedia page. It'll explain it. It's just, like I said, it's incrementing a number. I like that. Vector clocks are complicated, and I don't know. It's good. It works for 90% of use cases, I think. Just have a number, increment it. Should be good. So, to make sure that we could send a lot of changes rapidly, we tried to localize changes down. So we decided that you cannot change 2 things at once. You can only change 1 thing at a time. This is very freeing. Again, it sounds crazy to a lot of people at first, but we have no joins, we have no transactions, we have no foreign keys, orphans are fine, we don't care. Because that means a lot of things can happen very quickly. We don't have to check anything, we don't have to coordinate anything. Pretty good. Basically, my philosophy is, if something's difficult, I don't want to do it. It's like I don't even want to come up with a solution. Like I just don't want to do it. And so how can I not have to do it? Since everything has its own clock, and since we have this Cerebro that knows all the rules of all the touching and propagates that upward, we don't need to do multiple changes at one time. We did make the rule that each change to each individual item is atomic. That's very important, because when you increment a number, you definitely want to know that it incremented. So I do recommend that. And we actually use Postgres for that, believe it or not. SQL databases are very good at saying, I really want to make sure this happens all at once. So we do a very special type of row locking when the numbers are incremented. Works very good. But everything else is async. We decided just no exceptions. We weren't going to cheat. We weren't going to try to optimize. And I think it's been very good for us. Again, it's allowed us to just create features without asking permission to make changes. I mean, we can move infrastructure around. Doesn't matter. Like, nothing ever gets affected like that. Sorry, one example I wanted to bring up again is like, we don't actually care if a parent exists, like through like a create, like just, we don't care, just put the parent ID in. If that ends up going to an app and it doesn't have that parent, it's not going to show it in the UI anyway, so we just don't care. So at the end of the day, it doesn't matter. Okay, so I guess I have some information. One of our rabbits, I looked recently, I don't know, this is back on napkin math, delivers about 3 billion events. Events was the thing that goes across the WebSocket, like I said, every day to several Scala applications. And then those applications will look to see like who is connected to the WebSocket, do they need any of these events? So they kind of sort through. That's a Scala Akka setup. Every WebSocket connection has an Akka actor, and it kind of then registers in a registry, very similar to like Elixir's registry. It's been very good. Rabbit is very good at delivering messages, and Akka is very good at determining if it should then forward it along. What's good about this is we don't have to pin WebSocket clients to specific WebSocket machines. They can connect to any of them, and then every Scala app receives every event in the system. We don't actually filter or do anything like that. We literally just send the entire event stream to every Scala machine, and we leave it up to it to do the filtering. And so far, we have been rewarded for being lazy. So we know that it only scales up to a certain amount. We just haven't gotten there yet, and I don't think it will. I think Amazon's creating better machines all the time. You know, Intel's helping us. I don't think we're going to have to change that ever. I mean, we don't really change a lot of Wunderlist anyway, so it's not going to change. We don't actually enqueue 3 billion messages, right? Rabbit creates them. That is huge, very big feature. We put things into Rabbit, and then depending on how many WebSocket machines there are, it will then fan out into 3 billion messages. That is fantastic. I mean, that's a feature right there. That is worth every, I don't know, penny. But Rabbit's free. Okay. What's good though, we add a new WebSocket machine, and Rabbit will scale it out for us. We don't have to do anything. It just binds, sets up a queue, binds the exchange to it, so it gets all the events, and then it has its own little registry to forward to WebSockets. It's perfect. I found some graphs out of context, always good. So this is an example of that asymmetric relationship. So that bottom line is what's going in, and the top line is what's going out. So Rabbit is doing all that work. Like, we don't do that. We didn't write that code. We're not going to write that code. So that's I think that's good. I don't know about you, but I love that. And that red line can go very high. I've seen it go very high before. So it can really multiply like it's its job, because it is. But this is an example of something that has a very symmetric relationship. So whatever we put in kind of goes out the other side. This is probably like task creates or something. I don't remember exactly. And then this is a graph of something that just doesn't do very much at all. We have a lot of rabbits that are less important, like I said, and so we have some that just kind of sit in their, pretty crappy EC2 machines, I think, and whatever. So it's nice that it can do that. It can scale from this crappy thing up to like really helping us. So cool. That's it. That's important. I have some other things I can run through quickly, and then we'll get to questions. So. Bindings are expensive. I don't know. I mean, I wish they weren't, because our original idea was that every WebSocket would create a binding so that we let Rabbit do the filtering. And it just turns out that's just, you don't want to create 500,000 bindings. It's just not a good idea. It doesn't work, basically. Rabbit will eventually just be like, no. And so we had to happen. because we tried it. That's how we learned about this stuff, is we would literally just try it and be like, oh, it's not working. Connections are expensive more than we thought, like as far as like actually being taxing on the machine. And so for very, very important rabbits, we just over provision. We just make sure that like we have a lot of room just in case we need to scale out the consumers. We don't want to all of a sudden, Rabbit, this guy's kind of slowing down because of the extra connections. Like we had it happen a couple of times, and we're like, just solve it with dollars and get it over with. So there's a thing called shovel. It was mentioned in a few different talks. You got to learn about the shovel. So good. You can be on one rabbit, and then in a bit, you're on another rabbit. That is big for us because, like let's say we wanted to upgrade a rabbit, but we don't want any downtime. We set up the new rabbit, we move the consumers over there, publishers over there, and then we shovel everything into the new one. So shovel basically just copies everything from one rabbit to another. That's what it does. At least that's what we use it for. I assume that's all it does. Maybe it does more. Fantastic. You can move across data centers with it. It really can do anything. So if you want to just copy from one rabbit to another, I really recommend getting familiar with this. This is a really good way to like when you screw something up to be able to fix it pretty quickly. And we did a lot of shoveling. HA is a big topic. We do not have a good story here with Rabbit, so we cannot recommend it, and we do not run any HA Rabbit. We do only dedicated rabbits. We did not get good performance, and they fell apart on AWS the minute we had abnormal load, and I just didn't have time. I was like, I don't know. And so it appears like I always thought that maybe we were doing it wrong, or like maybe things are better now. So I don't want to say like it's bad. We never got it to work. So I recommend you look into it. It's an important topic. I think basically you just need to answer the question, what do I do when Rabbit goes down? So we just answered it by coming up with a data loss backup plan. We have a way to look at the database and infer most of what should have happened. And so we can it takes a long time, but we can figure out like, okay, what should have been in Rabbit? And then we'll just go try to put it back. We've only had to do that twice. We call it the replayer. It worked. It worked enough that we felt like we recovered from the data loss problem, and so we considered it a success. This is an option. Like you could do this. So because we did, I recommend looking into all options. It might be that like a lot of people say like maybe you actually don't need durable messages because like with this replayer thing, maybe we don't need durable messages. Maybe we could turn it off and have better performance and pay less money. I don't know. It's worth looking into that stuff. So, as an aside, there's no way you could know if it's going to work for you if you don't have a way to push it. And I do not know of a way to push it, and so we made it. My friend Duncan Davidson, who worked with us, he created a Scala program where he literally built out basically Wunderlist, the app, and it would instantiate hundreds of thousands of customers per machine, and then we would launch like a bunch of EC2s that had all these customers, and they would actually collaborate with each other. And everything fell apart. Everything. That's when we always had our HA problems. It was the worst. It was literally like the worst days ever. And it made, when we actually launched the product, like nothing. Like it was like, we were like, why are the graphs not spiking? And we realized like we were way too aggressive with our testing. But it's a really good idea. You should do it. Shout out to Duncan. He's the best. He did all that stuff for us. You got to do it. You got to write something that really breaks everything so that you'll know where it'll break. Like I said, we do functional sharding, so we have a lot of dedicated rabbits. This worked really good for us. I recommend it if you don't know what to do. It's a fine place to start, but definitely, like I said, do your own research. This is kind of how we approach app development. Anything that the customer doesn't touch, we want to crash immediately. Anything the customer touches, don't ever crash. I just think that's really, that's how I like it to work. So one way we do this is you throw away messages you don't understand. This allows us to iterate our message schemas and make breaking changes without actually crashing apps. And so I recommend this. Log it, like log that, hey, I saw something I didn't understand. But we did have a bug in one of the apps in the code that discards messages it doesn't understand, which caused it to crash. So you definitely want to really verify that code works, because that was embarrassing. But we fixed it, and then yeah. Another thing is that Bunny was problematic. So it was a Ruby shop at first. We have a lot of languages now. Bunny was problematic. We actually made our own gem called Watership to wrap and try to control Bunny. And I went back and looked at the commit history, and it's just back and forth rescues and timeouts, and I don't think it looks to me like we never actually got it solved. We had times where boxes would have the messages waiting in like basically in the QoS like buffer and not doing anything. And we think it was like an internal thread and Bunny had crashed and nothing restarted it, and we just, I don't know. We fix it by just restarting machines periodically. We never keep any machine longer than a couple days, and so sadly that's our solution for that. We didn't have the same problem. I think the Java library like didn't have any problems for us, so all of our Scala apps and Clojure apps never have a problem. So. Another thing that really surprised us was backlogs are like way worse than you think. I mean, it's already bad because it's like, oh no, why are we not like working off fast enough? But we think, I can't prove it, but we think that a large backlog is slower to provide messages to consumers than one that is emptier. And so it actually becomes like slower to get stuff to do as you have more stuff to do, which is very anxiety inducing. We actually had one time where we had to just flush and run the replayer, and kind of throttle the replayer, because we just felt like, based on what we were seeing, we were never actually going to be able to work it off because stuff was still coming in and it was building up and then it kind of was slowing down. Now again, maybe we just don't know what we're doing, but I don't know. It hasn't happened recently. I mean, we're on pretty big machines now. I think we paid our way out of it, but I don't know if this is a thing. Can you let me know? If this is like the way it works, or if it's just like, no, you're crazy, that's fine too. I recommend you don't host your own Rabbit unless you are literally a Rabbit hoster, mainly because just spend time working on your product and using Rabbit. To me, that's the fun part. Now, if you like, I mean, if you're interested in like how Rabbit works, of course, whatever, do whatever you want. Don't listen to me. But if I'm building a product, what do I not have to do, And this is something, again, Carl helps us with that, so. So after the acquisition, Wunderlist has been in maintenance mode. The Microsoft asked the team, like, what do you all want to do? I guess I was part of the team then, so it's like, what do we want to do? And overwhelmingly, people actually wanted to start over and do a new app. And so that's what they did. So it's just been running in maintenance mode. It's not turned off. We don't, I mean, as far as I'm aware, like, no one really, there is alerting, but we don't get alerted. Nothing goes wrong. Like, it kind of just runs. And I just want to tell you that because, like, that's possible. I think a lot of people feel like that's not possible to build an app that runs. But yeah, it's good. I think Rabbit is actually a big part of why. Like, we trusted it. Like, we were like, Rabbit's probably not going to kill us. And then we had confidence from that. And I think that allowed us to focus our anxiety elsewhere and like make the things that we were doing more robust, or maybe there's exceptions and we're just not logging them, right? And then that's also great. So so this is my takeaway. Rabbit has worked well for years. We have Rabbits, I think, that have been running for years. I don't know. Who knows? We don't worry about it. It runs. It's the best part of our architecture. It's the part that we didn't make. And so, yeah. I really appreciate that it keeps working. I really appreciate, actually, I think earlier today, he mentioned, there might be breaking changes in the future. I really appreciate that there aren't, aggressive breaking changes all the time and things like that. I don't know. I like it when things work and I can do my job. So please tell me if I missed anything or if there's something you're interested in. This was the question I was trying to answer. Should you bet on Rabbit? I would say yes. And then now I hope you can ask me questions and stuff because I have a lot of time left. So.
Thank you, Nathan. Let's get going with the questions. So we've had a lot of questions from this side this morning. I wonder if we can get some from this side too.
Worst nightmare.
Note that Jack moved from that side to this side, so this side is still.
They gave me some money. I was just very curious about the Akka side and how you're kind of integrating with the web sockets. That's it. Thanks. See this side again. Yeah. And if it's been blogged about, or if you got anything to point, because it sounds quite interesting. It's quite interesting architecture of how you did that.
Yeah. So Akka, there's a library called Akka HTTP, and it has, I think it has WebSockets in it. So it will do the instantiation of an actor for you. And then from the Rabbit consumer, we literally just do like the Scala like message send thing that they have an operator that they've introduced. Akka's introduced, I think it's the exclamation point. So we just kind of like I think there, yeah, and then we set up a registry process, which is basically exactly like the Elixir registry, where every actor that boots will register itself under like an ID. And then we have those IDs on the messages that we send. And so it's basically user ID. So then every event that comes through, it'll just try to spam it to a process with that event, with that user ID. And if it's not there, the registry just throws it away. So it's actually not very sophisticated. And if you look up Akka HTTP or even just a Play framework, they also have WebSockets. They do all that for you. Like we don't. I don't want to do that.
Okay, thanks. Very funny. Thank you.
Yeah, on a similar subject, did you look at the Microsoft actor models at all?
Yeah. So Orleans is the open source one that like Halo was built on, and I've talked about this many times I spoke at a few Beam conferences. I don't remember what they're called, Code Beam, and they're very interesting. But Orleans is C#. I mean, I don't want to write C#. There is also Service Fabric, which it turns out Service Fabric has actors, but they don't actually. I got to finally meet the people who made it because I worked there, and I just happened to be in their building one day. And they don't actually recommend that you use the actors in Service Fabric because they're actually pretty slow to instantiate. What they've actually created is these stateful collections or replicated collections. I don't know. Either way. Basically, you can have an array that is consistent through the cluster, and they recommend you use those types of data structures that are cluster consistent instead of creating an actor for everything. So it would be kind of similar to having like a callback that would, you'd have a lot of callbacks for like each request or WebSocket that would operate on this one array that would just kind of maintain consistency. So that's what they recommend. Orleans is very good. The thing I don't like about it is that the process registration table is eventually consistent, even more so than global. Global is eventually consistent in a network partition, but this one's always eventually consistent. And so depending on, they use a DHT to get the process IDs around. And so it could take time for each server to find out that a actor of a certain ID has booted somewhere else. And really interested in somebody coming up with something that's either backed by Zookeeper or uses Raft or something, so we can have a consistent process table in some implementation. I mean, I guess I'm certain Akka probably has it, but Akka has everything, right? And I just can't find it. So they've implemented every computer science possibility, right? So. But yeah, I would like to see that in Elixir or Lang or a language that I enjoy typing.
Do we have one more question?
It was a great talk. So I've heard that sort of Rabbit's extremely flexible. You can use it in all sorts of different ways. Are you doing anything weird with it, where you're like possibly the only people doing it, like writing strange plugins or anything like that?
No. I mean, we probably have, but we don't, like, not as a practice. Like, maybe we've done weird things to be funny just internally or something, but we probably turned it off. No, it's important. And so all the things that are important, I try to keep really dumb. And again, anytime I say I, it's we. I should say we. It's just we really, like, I just don't want to be paged. So that's really it, right? I mean, like, page duty. I don't want it to happen. So, any other questions? Or I think we technically have like 5 more minutes. Or we can just hang out. It's fine. Oh, there's a question here.
Hi. Just a little clarification. When you said you don't use HA, do you mean you don't use Rabbit clustering, or you don't use like mirror queues, that sort of thing?
We don't use any of it. Yeah. Yeah, we just have one Rabbit for each functional thing. And so if it dies, we make another one. Yeah, that's what we do. So. So, and like I said, we've only had to do the replayer thing twice. Like, it doesn't die. Is actually one of the things that's kind of great is it doesn't die. Or if it dies, it'll crash and restart. That's fine if you're persisting messages, right? It's not going to lose a message. If it says it got it, it did get it, which is nice, right? That's a good thing. We trust it. We trust Rabbit. We trust Postgres. Those are the two things that we think made it to disk, right? Everything else we assume never made it anywhere, and it's probably gone. So, yeah. Okay. Cool. I think I'm going to be done now. So
All right, great. Thank you, Nathan.